Good morning to all. I am Sumati. In this video, we are going to discuss about go back and sliding window protocol. What is sliding window protocol? Sliding window protocol is a key computer networking technique used for controlling the flow of data between the sender and the receiver. It guarantees data that is being sent consistently and effectively, allowing many packets to be sent before requiring any acknowledgement for the first frame being sent. It maximizes the use of available bandwidth. This protocol is is this protocol is used in data link layer and it is helpful for sequential and reliable data delivery of data frames. The sender can send multiple frames at a time and the receiver receives frames and sends back the acknowledgement to the sender. The acknowledgement lets the sender to know that the particular frame is received by the receiver correctly. The sliding window protocol uses the mechanism of sequence number. The sender associates the sequence number to the data frames so that the receiver can use the sequence number to arrange the frames in order if any frame was retransmitted. That sequence number also helps the receiver to identify the lost or damaged packets. In this sliding window protocol, we use an imaginary box called window to hold the frames at the sender's end and the receiver's end. The window on the sender's side covers the sequence of packets that are sent. On the other hand, the window on the receiver's side covers the sequence of packets that are to be received. The sender's window size is represented using WX and the receiver's window size is represented using WR. The sliding window protocol uses full duplex for data frame transmission. The sliding window protocols is also used as the TCP or transmission control call. There are two types of sliding window protocols, that is go back N ARQ and selective repeat ARQ. In this video, we are going to discuss only about go back N ARQ. Go back N ARQ is one of the sliding window protocol strategy which is used for reliable in-order delivery of data packets, and this concept makes use of the timer where when the receiver receives the correct frame, it sends back the acknowledgement. Once the sender gets an acknowledgement for the data frame, it shifts its window forward and sends the next frame. If the acknowledgement is not received within the specified period, then all the data frames starting from the last frame are retransmitted. In the go back N ARQ, the sender's window size is taken as N, but the receiver's window size is always 1. Hence, the sender can send N data frames at a time, but the receiver can receive only 1 frame at a time. The go back N ARQ is used for noisy channels and it can manage the flow and error control between the sender and the receiver. In go back N ARQ, we retransmit all the data frames starting from the last or damaged frames. The acknowledgement has the sequence number of the frames that helps the sender to identify the last frame. The sender sets the timer for each frame, so when the timer is over and the sender has not received any acknowledgement, the sender knows that the particular frame is either lost or damaged. The acknowledgement has the sequence number of the frame that helps the sender to identify the last frame. If suppose the sender's window size is N and the receiver's window size is 1, the sender waits for a period specified by the timer before sending the frame again. Hence, the go back N ARQ is a slower protocol than selective repeat protocol. In go back N ARQ protocol, the efficiency is N divided by 1 plus 2 2a, where a is the ratio of propagation delay versus the transmission delay and n is the number of packets sent. This concept is quite easy to implement, but here a lot of bandwidth is used in case of higher error rate for the retransmission of entire window every time. Here is an example of how go back N protocol works. We can imagine that the sender window size is 4. This means that the sender can send up to 4 frames without needing acknowledgement for each frame. Here the sender can send as the window size is 4, the sender can send 0, 1, 2, 3 frames at a time without receiving any acknowledgement. Second step, the sender has sent the first 4 frames, that is 0, 1, 2, 3 is being sent from the sender to the receiver and it waits for the acknowledgement. We all know that the sender's window size is 4 and the receiver window size is 1. After the first frame is being received by the receiver sends the acknowledgement for the first frame, that is 0th frame. After the acknowledgement is received by the sender, then the sliding window slides from 0 to 1, and when the window size is 1, 2, 3 and 4, next the 4th frame is being received. Here this concept is said to be a sliding window protocol, where 0 indicates that the acknowledgement has been received and 1, 2, 3 and 4 is the frames that has been transmitted but acknowledgement has not been received, and 5, 6, 7, 8, 9 indicates that the frames has to be sent. Now the window has moved from 0 to 1 right side. Now after receiving the acknowledgement for 0th frame 4 has been sent to the receiver. Now after the acknowledgement of the first frame is being sent, now the next, even though 4th and 5th frame are being transmitted, but again it will be going back to 2nd frame, 3rd frame, 4th frame and 5th frame will be retransmitted again. Here in this slide we can notice that the 2nd frame we have not received the acknowledgement. So even though we have transmitted 4th and 5th frame, it is discarded and again we are transmitting 2, 3, 4 and 5. This procedure of repeating again from the last frame is said to be as going back to the last frame and repeating everything which has been retransmitted is said to be as go back N protocol. Here even though 2, 3, 4 and 5 has been sent already, we have not received the acknowledgement for 2nd frame. So we are moving again back to the 2nd frame and retransmitting 2, 3, 4 and 5. The frames which has been sent already will be discarded. This picture shows clearly how frame number 3, 4 and 5 are being discarded and the frame 2 is being last, and we know this that the frame 2 has been last by knowing that we are not receiving any acknowledgement for this frame number 2, sequence number 2. Characteristics of go back N protocol. The sender window size in the go back N protocol is N. The receiver window size is 1. If the sender does not receive an acknowledgement for a single frame, it retransmits the entire window beginning with the problematic frame. Advantages. When the sender detects the frame it has sent, it is corrupted. It does not just retransmit the corrupted frame, instead it retransmits the entire window of the unacknowledged frames starting with the corrupted frame. It allows the sender to send multiple frames consecutively without waiting for acknowledgement after each frame. Pipelining is present, which means that the sender can send a continuous stream of frames within the window without waiting for individual acknowledgements. Disadvantage: if the acknowledgement of one frame is not received, the entire window is retransmitted instead of only the corrupted frame. Retransmitting the entire window on detection of corrupted frame increases congestion and time consumption. The terminologies related to sliding window protocol are transmission delay, propagation delay, efficiency, effective bandwidth, capacity of the link. Conclusion: the sliding window protocol is a data link layer protocol that is useful in the sequential and reliable delivery of data frames. Go backend is a sliding window protocol used in computer networks, ensuring reliable data transmission by allowing the sender to resend unacknowledged frames. In a noisy channel, go backend ARQ retransmit frames if they are corrupted, enhancing data reliability. The formula for go backend utilization is equal to efficiency into 1 minus BER to the power n, where BER is the bit error rate and n is the window size. And thank you.